All right, boys, for 9-2, we're going to intro to circles. We're going to have a whole chapter on circles. And that chapter is going to be a lot easier if you learn what I'm going to teach you today. I'm going to teach you a lot of stuff that isn't really clear in the book. It's there, but it's not very clear. So I've created formulas. Well, I haven't created formulas, but I have written down some formulas that are nice and clear for you to understand. If you read this section on your own, you'd probably get it, but it's going to be a lot more difficult to understand. Okay, so let's first look at a circle. I know that everyone has seen circles before and everyone thinks they know what circles are. Let's just make sure that we understand what it is, okay? First of all, let's talk about the radius. The radius is a line segment that extends from a point on the circle's circumference, and it extends to the center. The center of a circle will always be labeled. So in this case, O is the center. It's actually called circle O. Okay, the center of the circle defines the name of the circle. So in this case, you have circle O. All right? Now, radius goes from the center to any external point on the circle. So this would be a radius, and that would be a radius, and this would be a radius, and that would be a radius, and this would be a radius. Think of a pizza or of a pie, gentlemen. When you have a pizza or a pie, and they cut it up into slices, you know, they try the best they can to cut it through the center, correct? So right in the center where all the pieces come together, those lines that extend to the crust of the pizza, that's the radius, all right? Diameter. Now, the diameter extends from one point on the circle all the way to another point on the circle, but it goes through the center. It goes through the center. So the radius and the diameter are related. If you see here, the radius, okay, right up here, radius, R equals diameter divided by 2. Radius equals the diameter measured divided by 2. And the diameter equals 2 times the radius. So the diameter is basically twice the radius, and the radius is half of the diameter. Now, you have this thing called a chord. A chord is a segment that goes from one end point of the circle to the other end point of the circle, but does not go through the center. So, here's a true or false. A diameter is a chord. It's true. But is a chord a diameter? No. No. Never. Okay? Thank you. Okay. I had some people say yes, no, never, sometimes. Okay, let's go over it real quick. If the definition of a chord is a segment that goes from one end point to the other end point, doesn't the diameter also go from one end point to the other end point? So the diameter is a chord. But is a chord a diameter? No. Very good. Thank you. A chord is not a diameter because it never goes through the center. So a diameter is a chord because it meets the definition of a chord going from one end point to the other. But a chord is not a diameter because it does not go through the center. It's kind of like a square is a rectangle, but a rectangle is not a square. Same difference. Only some rectangles are squares? No. Squares are rectangles, but a rectangle is never a square because a square is defined by having 4 equal sides. So a rectangle will never be a square. But a square will be a rectangle because opposite sides are congruent and opposite sides are parallel. So again, a diameter is a chord, but a chord will never, ever be a diameter. Hint, hint, That may be a test or quiz question. So if you want to answer it the way you want to answer, that's fine, but it will be wrong. A diameter is a chord because it meets the criteria of a chord. But a chord is not a diameter. Yes, sir.
The definition of chord also that it can pass through the middle?
Yes, a chord's definition is a segment, a line segment that goes from one endpoint of the circle to another endpoint of the circle without going through the center. So relax. So a chord can never be a diameter. But a diameter is a chord because a chord is simply a segment that goes from one endpoint to the other. Doesn't a diameter go from one endpoint to the other endpoint? Yes. Guys, you're arguing with me, and unfortunately you're wrong. A diameter is a chord because by definition a chord is a segment that goes from one endpoint to the other endpoint. Does a diameter go from one endpoint to the other endpoint? Yes or no? So a diameter is a chord. But a chord is not a diameter because a chord does not go through the center. Yes, sir.
But like, what's confusing me, you said like a chord can't pass through the middle?
Yes, a chord. If a chord goes through the middle, then it's called a diameter. No, a chord cannot be a diameter. A diameter can be a chord. Exactly. Guys, look. Guys, look. This is a diameter. Okay? But a diameter is a chord because it goes to the center. However, this is a chord. Is that a diameter? No. So a diameter is a chord, but a chord is not a diameter. Now let's continue. Let's talk about arc. Oh, sorry. Let's mention arc here. The arc. Okay? When we're talking about arc, an arc is kind of, let's go back to the pizza. It's kind of the crust part. You know when you take a slice from the pizza, you have that kind of curved crust at the end? That little curve, that point from here to here, let's highlight it so you can see it. This part right here, that's an arc. An arc is simply a fraction of a circumference. That's all it is. The arc is a fraction of the circumference. And you can find the length of an arc, okay, very easily. And you can also find the angle measure of an arc. And that's what we're going to talk about right now in a second. So when we're measuring the arc here, okay, there's a couple of different things that you can do using the arc. First of all, let's find how the measure as far as degrees of an arc. Because we know that a circle has 360 degrees in it, correct? All right. Sometimes you're going to have something like this. Let's call this circle O. This angle here, that's called a central angle. And it's a central angle because it's an angle formed inside of the center of a circle. Does that make sense? This angle, we'll call it X degrees. The arc, let's go ahead and call this A and B. So angle AOB, which is the central angle, equals X degrees. Arc AB, literally you make a little arc over the letters. AB is going to also equal X degrees. When you have a central angle, the arc measure in degrees is equal to the central angle. When you have a central angle, the arc measure in degrees is equal to the central angle. When you have a central angle, the arc measure is equal to that central angle. Does that make sense? Okay. Now, there's also something called an inscribed angle. And an inscribed angle is something like this, gentlemen. This is called inscribed angle. And we'll learn a lot more about this later, but again, you need this introduction. Now the angle here, let's call this A. The center's here. Center has nothing to do with it in this case. Let's call this B, and let's call this C. We'll call this is X degrees. So angle, inscribed angle ABC equals X degrees. Okay? Then arc, very good, son. AC is going to equal twice the inscribed angle, 2x degrees. So if ABC is 40, arc AC is 80. Vice versa. If arc AC is 100, then angle ABC is 50. So central angles, okay, the arc that is opposite of the central angle will equal the central angle measure in degrees. When you have an inscribed angle, the side opposite the inscribed angle will be twice the measure of the inscribed angle. Does that make sense, gentlemen? Are you sure? Okay, thank you. Let us continue then. Now, we can also find arc length, which this is an actual length. This is a distance. It is not a degree. And we can also find sector area. So let's go ahead, and actually that's not looking like a circle at all. That looks like an ellipse. So let's do a circle. All right, much better. Okay. Let's say I give you the following, gentlemen. I give you this right here. I cut this like this. I make this a 90. This is what symbol? Pi? Pi? Okay. So in this case, when you want to find the length of AB, not the measure as far as an angle, but a length. A length is not a degree. Okay? The measure of the arc, that's in degrees. So measure of an arc is degrees. Length of an arc is an actual distance. Okay? Length is a distance, not an angle degree. You with me so far, gentlemen? We promise? Okay. Now, the arc length is going to equal the central angle, which is in this case 90, over 360 times the circumference, pi d, or 2 pi r. Pi d is the circumference. Circumference equals pi d, or 2 pi r. You should know that from years past, but if you don't, it's right there. So this is basically, look at it. Look, think what we're saying. This is the whole circumference, right? Right, guys? Aren't we finding a fraction of that circumference? Well, how do we get that fraction? Well, the central angle over 360, isn't this 1/4 of the circle? So wouldn't it be 1/4 of the circumference, the distance around the circle? So in this case, in this particular case, this would equal 1/4 of, let's go ahead and put a radius here of, let's say, 3. This would be 1/4 of 6 pi. So this would equal 3 pi halves. And let's say this was in inches. It would be inches. No, why would you need a calculator for this? Why would you need a calculator for this? You leave it just like that. Yes, sir, you may leave it in pi. Yes, sir. I give you my word. Okay? If I wanted you to calculate it, I will let you use a calculator for that. Yes, sir. Okay, now, is that making sense for everybody? Okay. Let's pretend that we have the following this time. Here's my central angle. I know it doesn't look like a central, but it is. And let's say I go 30 here. And I say that the radius is 5. And I say, I want you to find a couple things. I first want you to find the arc measure. And then I want you to find the arc length. Okay, so the arc measure would be what? 30, because it's the same exact thing as a central angle. That's why I put the arc measure right above here in parentheses, above the central angle, because they're one and the same. Okay? So I have 30 over 360 times circumference. Isn't circumference here 10 pi? 2 times the radius times pi? So this 0 there. So this is going to be pi over 12. That will be the distance of arc AB in this case. So arc AB, the length is pi over 12. The arc measure is 30 degrees. What do you mean happens to the 10? Yeah, can I cancel out this 0 with that 10, son? So then I have, I'm sorry, I screwed up here. My bad. My bad. Let me do that again. I apologize, everybody. The arc measure is 30. The arc length is 30 over 360 times 10 pi. Sorry, I became overzealous. So this would actually be 112, 5 sixths. Okay, sorry about that. 5 pi over 6. That would be the arc length, and the arc measure would be 30. Does that make sense? You sure? Okay. Last thing that we have to learn today. Let's talk about sector area. Now, what's a sector? Well, a sector, going back to the pizzas and the pies, a sector is basically a slice. That's what a sector is. For example, if I have this here, like this, so this is 90. This guy that I'm going to outline in blue, that's like a pizza slice or a slice of pie. That's a sector. It's a sector. A sector is basically a slice of the pie. That's what a sector is. Now, to find the area of this sector is ridiculously easy. If you think about the whole circle again, isn't the sector basically a fraction of the whole area? Exactly. So the formulas are very similar. The area for this guy, let's go ahead and call this AB, and let's call this circle D. Area of sector, let's go ahead and put it like this so you can understand. Area of sector ADB equals central angle, which is 90 over 360, times pi r squared. Let's go ahead and make this a 3. So pi r squared, 9 pi. So this becomes 1/4. So this is 9 pi over 4. And whatever units squared. Does that make sense, gentlemen? Because this is really, really easy. And at the same time, really, really important. Come again, son? That's units squared. Yes, sir. Does that make sense, boys? Okay, now, we ain't got much time left, but let's go ahead and try to do some problems. I'm going to kind of go through these relatively quickly, but they're in your book, so you can follow with me. Okay. Problem 1. It says, find the circumference and the area of circle P. So they give you this circle, and they tell you that it's circle P, and they tell you that you have 2.7. They want to find the circumference and the area. So the circumference is going to equal 2 times the radius times pi, and the area is going to equal pi times the radius squared. Okay? So circumference, when you do that math, is going to equal 5.4 pi units. Again, if you wanted to calculate it, you go 5.4 times pi on your calculator and you get it. The area here is going to be 7.29 pi units squared. So it's pretty straight up, the circumference and the area. Is everyone with me so far? Yes? Okay. Problem 2. For problem 2, they give you the following. They give you the following, guys. They give you this circle here, okay, and the center is right there. Let's get rid of this guy. Okay, the center is right here, and they want to find A, and here's B. This is 08, and this is 80. They want to find for A, the measure of arc AB, and then for B, they want to find the length of AB. Please remember that this is very, very simple. What would A be? What would the measure of AB, of arc AB be? 90, guys. Yeah, this is the x-axis and the y-axis, so that's a 90. Central angle is equal to the arc that it's opposite to, so that's 90 degrees. You're done. What is the arc length? Central angle over 360 times 2 pi r, the circumference, exactly. So it'd be 16 pi. Let's go ahead and reduce this. That's 1/4 times 16 pi. So that would be 4 pi units. Does that make sense, gentlemen? Are you sure, gentlemen? Okay. Let us continue. Problem 3. For problem 3, they give you again an x and a y axis. So we have an x and a y axis. They give me a circle. So I've got a circle. Okay? And they have R, P, A, and they have this as 0, 12, and they have this as 12, 0, and they want to find the area of the shaded region, in other words, the sector area. So the area of this shaded region, or the sector area, would be central angle over 360 times pi r squared times the radius squared. So it'd be 144 pi. This breaks down to 1/4. You can take 2. Actually, you could take 4 from both of those. So that's going to be 36. 36 pi units squared. Yes, units squared is super, super, super important. Okay? Guys, you still have to cover problem 4 through 7 at home on your own. It's very simple. Homework is valid. Have a great day. God bless you.